So what are the things that are necessary for a reaction to occur? In this video, I will be explaining the very special circumstances that are needed and necessary for a reaction to take place. And we will use that knowledge to explain how we can speed up a chemical reaction. So the first thing you need to know is, in order for any chemical reaction to take place, reactant particles must collide. They must smash into each other, and they must physically come in contact with each other in order to form new product particles. And then two things need to happen in this collision. It can't just be any old collision of two reactant particles. The collision has to be with the reactant particles in the proper orientation. So in this nitrogen monoxide and ozone example, the nitrogen monoxide and ozone have to hit each other so that they're facing the correct direction, and the particles, the atoms in each molecule, specific atoms in each molecule, come in contact. It can't just be any old collision. Otherwise they'll just bounce off of each other. The second thing that needs to happen is the reactant particles must have enough energy. They need to be moving fast enough so that their collision has enough energy to break the chemical bonds that are in the reactant particles and form new chemical bonds in the product particles. So they have to be moving fast enough and have enough energy. Otherwise, they'll just bounce off of each other. Now, collision theory states that in order for a reaction to occur, particles must collide with the correct orientation and sufficient energy. So every one of the things that I'm going to list on the next slides are going to have to do with bettering the orientation or increasing the amount of energy. So we want those particles to collide, and we want them to have the correct orientation and the correct energy. So one thing we can do to speed up a chemical reaction is we can decrease the volume of the container. Now what this does is, if we have these 5 particles in this container, if we have these 5 particles in this container and we squeeze them and we lower the volume, we squeeze them so they're closer to each other, decreasing the volume will increase the number of collisions. And if we increase the number of collisions, then the chances of getting an effective collision go up. So we're increasing the number of collisions with the correct orientation. If they're hitting each other more frequently, then they're more likely to react. The next thing we can do is we can increase the concentration of the reactants. So we're putting more particles into the same amount of volume. So here we start off with 5 particles and we end with way more than that. By increasing the concentration or the molarity of the reactants, we are increasing the number of collisions that will occur between reactants, therefore increasing the rate of reaction. The next thing we can do is we can increase the temperature of the reactants. So if we have a reaction taking place at a specific temperature, if a certain number of particles will react. But if we heat up the reaction or the reaction mixture or the environment where the reaction takes place in, then we will increase the speed of the particles. So they will not only collide more frequently because they're moving faster, but they will have more they'll have more collisions with a sufficient amount of energy to actually turn into products. So two things happen when you increase that temperature. We increase the number of collisions and we increase the energy of each collision. So the first example there, the first picture, showed the particles with enough energy to react, and the second is when we increase the temperature, more particles had enough energy to react. So we get a faster reaction rate. Remember, these are all about speeding up the rate of a reaction. The next thing we can do to speed up the rate of the reaction is to increase the surface area of the reactants. So if we have this cube here, only certain parts of that cube are able to react. But if we break it up into smaller pieces, then we're exposing the inner layers, and those inner layers are then able to react. So if we increase the surface area, we will increase the number of collisions with reactant particles. The last thing we can do to speed up a chemical reaction is to add a catalyst. And what a catalyst does is it changes the mechanism of a reaction. So it changes the path that a reaction takes, and it takes a newer, simpler, lower energy path. So it lowers that amount of energy needed to have a productive reaction. So with the catalyst, there's less energy that you have to put into the reaction, and without a catalyst, you'd have to put more energy into that reaction. So adding a catalyst speeds up the chemical reaction by lowering the amount of energy necessary for that reaction to take place. And it does that by changing or altering the path the reaction takes to complete and create products. Now, one thing that's important to note is that some catalysts actually increase or change the orientation of the molecules, so they improve the direction that the molecules are facing so that more molecules can react in the correct orientation. And there are specific catalysts that do this, and they're specific biological catalysts that do this. And those biological catalysts are called enzymes. Those enzymes, and we have them in our body, they speed up all of the reactions in our bodies. Enzymes position molecules in a way so that only the part that needs to react is exposed and the rest of it kind of isn't, and it just moves them around so that they have the correct orientation to react. So we're not just having tons and tons and tons of ineffective collisions. It lines them up in a way or positions them in a way to have a greater percentage of effective collisions, because that's one thing that's necessary for a reaction to occur.